We finally see the real damage to James Webb. 2 more helicopters are going to Mars. Watch out, the sky might be falling. NASA needs your help in designing a telescope and teaching robots to die. Hi everyone, I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy news journalist for over 20 years. This is our weekly Space Bites news segment. Let's get into the news. We finally know how bad the damage is on Webb. A few weeks ago, we reported on a fairly surprisingly large micrometeorite strike that hit James Webb Space Telescope. And last week, NASA released a very detailed report on how Webb is going so far, and they included a section on the micrometeorite impacts that have happened. To date, there have been 6 impacts on Webb, so about 1 a month while it's in space. And this is what they expected. But the one was surprisingly large and actually caused some lasting damage to the telescope. It hit segment C3, which is down on the bottom right-hand corner of the telescope. And we've got some pictures. You can actually see the damage that was done to that one mirror segment. Now, according to NASA, the damage is detectable, and they were able to reorient that mirror to minimize the amount of damage so that that segment is still outperforming the original expectations for how it should be doing optically. And then, of course, when you add in all of the segments, the entire telescope is doing dramatically better than what they anticipated. So it's going to happen. There's going to be more of these impacts throughout the lifetime of the telescope. Hopefully, none will be as bad as this first one, but still, don't panic. This is to be expected. It's still producing some amazing images. And speaking of images, here is an amazing photo of galaxy IC5332. And this is another spiral galaxy that was imaged by the James Webb Space Telescope. And just for comparison, here's what this same galaxy looks like when it was photographed by the Hubble Space Telescope. Now, the image processing, once again, was done by Judy Schmidt, aka Space Gek on Twitter. And she is, in my opinion, the best image processing person out there. And so she was able to dig into the raw Webb images, pull all this data down, convert it into layers into Photoshop, and work with it until she produced this image. She used 4 separate data images from Webb, each one corresponding to a different wavelength of infrared light. And then she merged the images together, one for red, one for blue, one for green, and then another which gave the background grayish tone of space itself. And what you're looking at is a galaxy, but you're really seeing the infrared bright parts of a galaxy. And these correspond to the spiral arms, the knots of gas and dust where new stars are being formed. And that's why it looks so different from a visible light telescope. Now, of course, you couldn't see this with your own eyes, but if you could, like, I don't know, feel the heat from a galaxy with your hands, but not feel the visible light, you would feel the heat. This is what a galaxy's temperature might feel like in the infrared. China has launched a new module to their Tiangong 3 space station. Now, this new module is their science module. It's called Wentian, and it was launched on July 23rd and docked with the station on July 25th. And this is the second to last new module that they're going to be adding to the station. There's one more module called Mengtian they're going to be adding in October, and then at that point, their station will be complete. This will overall make the station about 1/5 the size of the International Space Station. And now for the bad news. When they launched that module, the booster rocket went all the way up into orbit. You've got this 54-meter long, 23 metric ton booster rocket that is now in orbit and is going to return on July 31st somewhere. We know that this booster is going to return about as far north as northern Spain and about as far south as the bottom of Africa, but it could really return anywhere in that zone. And we don't know where because it all depends on the atmosphere of the Earth, how much air resistance the booster is experiencing. And so as that date gets closer and closer, astronomers will be able to work out with more accuracy where it's probably going to be coming down. And so when this usually happens, this has happened many times in the past, as we get closer and closer, you'll be able to track the location of the booster and we'll know which orbit it's actually going to come crashing down. Most likely, of course, it's going to crash into the ocean, but there is always a chance that it's going to crash on land and cause damage. So just keep an eye out for a booster rocket returning from space. Now, this has happened before with boosters making it all the way to space from China. And the way they would fix this is to save a little bit of fuel on the rocket so that it could actually do a controlled burn at the appropriate place and crash itself deliberately into the ocean, as opposed to it just coming down in a random area. So hopefully this one won't hit anybody, and hopefully in the future, China will take a little more responsibility for their booster rockets. But if you're wondering, what are your chances of getting hit by a piece of space debris? The chances are very low. When you think about some really rare things, about 13 people a year are crushed by vending machines. 10 people a year die from shark attacks. Some researchers have estimated the chances of an upcoming piece of space junk actually killing someone. It's about 6 to 10% over the next decade. So definitely less likely than being crushed by a vending machine, but still not zero. Of course, one of the big problems is that the people who can be hit by the space debris are probably not the people who actually launched the rocket. So just another example of the tragedy of the commons. 2 more helicopters are going to Mars. NASA and ESA are in the process of designing their sample return mission. This will be a mission that will be flying to Mars in 2027 and 2028. There's going to be 2 separate spacecraft. One will be an ascent vehicle. It's going to fly to Mars, land on the surface, and then it's going to wait for samples, and then it's going to fly those samples up to space. It's going to meet with the orbiter portion of the mission, which will gather the samples and fly them back home to Earth. The 2 missions are going to be launching in 2027 and 2028. And as part of this design process, NASA and ESA gave us a bunch more sort of refined ideas about how this mission is going to work. And originally the idea was that they were going to send a chase rover that would land and run along the surface of Mars, picking up the samples and then bringing them back to the ascent vehicle. But the new plan is that Perseverance itself will keep all of its samples on board. It will arrive at the ascent vehicle, it'll hand over all the samples, and then it will carry that to space. But they're also going to be adding 2 helicopters similar to Ingenuity. And so these helicopters will be able, theoretically, to gather samples on their own as well. And so if Perseverance has too many samples and it just can't hold on to them all with its hands, then it's going to be up to these helicopters to gather up additional samples and bring them back to the ascent vehicle. Perseverance has already collected 11 samples, and so it's probably going to bring a few dozen back to the ascent vehicle. There's a pretty cool Easter egg in Google. If you search for the Ingenuity or Ingenuity helicopter, you get this tiny little Ingenuity helicopter flying around on your search engine, and it will just fly around back and forth while you're working with Google. It's pretty cool. Check it out. We might need to teach robots how to die. I'm sure you're familiar with this idea of von Neumann probes. This is the idea that was popularized by John von Neumann decades ago. He said that you could build a self-replicating robot probe. You just send one or a few out into space. They go to a star system. At that star system, they manufacture copies of themselves. Those go to other star systems, make more copies of themselves, and so on and so on. And in fact, if these spacecraft are able to travel at about 10% the speed of light, you only need about 10 million years to fully explore the entire Milky Way, which is pretty great. I mean, can you imagine us getting detailed information from every single star system in the entire Milky Way? We just have to wait 10 million years. Now, the downside of this idea is, what if you don't turn them off? What if they just keep replicating? Well, then they would go and they would eventually turn the entire Milky Way into self-replicating robot probes, a kind of gray goo berserkers. So that's a bad idea. So researchers are suggesting that we need to figure out a way that we can turn these robots off once they've built enough copies of themselves. And it's similar to what we have in our own DNA. We have these things called telomeres, which are at the ends of our DNA strands. And every time the cells replicate, the telomeres shorten. Eventually, the cells are no longer able to replicate, and so you don't end up with just never-ending replication of your cells. Of course, that's why we get old and die, but still. So we could see these robots having a set life, and then they stop replicating themselves once the entire Milky Way has been fully explored. Of course, it's science fiction, but it's a really cool idea. Maybe we don't need to start thinking about it quite yet. The most sensitive dark matter detector has come online. Now, we still don't know what dark matter is. And so the ways to search for it are numerous. There are telescopes that are trying to map out dark matter across the universe. There is the Large Hadron Collider that is attempting to manufacture dark matter here on Earth. And then there are experiments that are listening for the impacts of dark matter onto other particles that we're familiar with. And a new, very powerful dark matter detector called Lux Zeppelin just came online. This is a giant tank of liquid xenon located in South Dakota, far underground. And so because it's so far underground, it's completely protected from cosmic rays and other forms of radiation that could interact with the xenon. And the hope is that some random particle of dark matter, whatever it is, will wander through this chamber, interact with one of the particles of xenon, produce a cascade of particles that are then detected by various sensors that are arrayed all around it. Now, they did a first run. They haven't actually detected anything, but it is the most sensitive one that's ever been created. And so hopefully in the future, it will be able to find particles of dark matter. And all of these experiments are very important. I mean, of course, it would be amazing if they actually found dark matter. Nobel Prizes all around. But the other job is to constrain dark matter, to figure out what it isn't. And so with the telescopes, with particle colliders, with experiments like this, astronomers are figuring out what dark matter isn't, trying to figure out what its maximum masses are, its minimum masses are, what its cross-section might be, how it may interact with gravity and electromagnetic radiation. And so over time, the places that dark matter can hide will just continue to shrink. NASA wants your help designing a starshade. A starshade is one of the coolest ideas that astronomers are thinking about as a way to be able to observe exoplanets. So consider this situation, right? You've got this sun-like star with an Earth-like exoplanet orbiting around it. Now, from our perspective, the star is about 1,000,000,000,000 times brighter than the planet. And so the planet will be lost in the glare of the star. The solution is that you block the light from the star, and then that way the planet will be revealed right next to the star. And one of the coolest ideas to do this is to build a starshade. This is a giant kind of flower petal-like spacecraft that flies out in space tens of thousands of kilometers away from the telescope, and then it passes so that the central part of the starshade blocks the star, but the planet is visible in the gaps around the petal-shaped formation. So far, these starshades have been proposed to launch with other space telescopes. Like you could launch a starshade to go with James Webb or with Hubble. But there's a really cool idea that you could actually launch one of these starshades and it could be used by observatories here on Earth. And so that would save you having to also launch a space telescope to go along with the starshade. And NASA is looking for the public's help to design these starshades. They want to figure out ways to fold them, sort of an origami problem, but also a materials problem, how to make them light enough, and how you could actually launch them into interesting orbits so that they would work with ground-based observatories. So if you've got an idea for a starshade, there's a $7,000 prize in it for you. Now, I did a really cool interview with Dr. John Mather, who's of course the mind behind the James Webb Space Telescope. He won a Nobel Prize for helping to map the cosmic microwave background radiation. And he is actually one of the greatest proponents behind this idea of a starshade that would orbit the Earth and be used by some of the biggest telescopes here on Earth. So you're definitely going to want to check out that interview that I did here on this channel. And I also did an interview with Dr. Marcus Jensen all about starshades. So if you want to understand more about starshades before you attempt that $7,000 prize, check it out. Lava tubes on the moon are surprisingly comfortable. The moon is an extremely inhospitable place. Of course, you've got this constant streaming radiation, you've got this low gravity, but the temperatures range. In the daytime, it's 127 Celsius. And then at nighttime, it goes down to minus 173 Celsius. So that's a gigantic temperature range. And as you can imagine, these vast temperature ranges cause all kinds of havoc on electronics, on heating, cooling systems. It's bad. But there's a place on the moon where the temperature stays exactly 17 degrees Celsius, or 63 Fahrenheit. And these are lava tubes. Now, these lava tubes are like the lava tubes that we have here on Earth, but they are dramatically bigger because of the very low gravity on the moon. Here on Earth, lava tubes can be tens of meters tall. On the moon, they can be hundreds of meters, even kilometers tall. You could fit an entire lunar base inside one of these lava tubes and have room to spare. NASA's Lunar Reconnaissance Orbiter has been mapping the surface of the moon, and it's found many examples of these lava tubes. It sees the collapsed skylight where there's a lava tube and the material has fallen down. So here's an example of one picture where you can see where the sun was almost directly overhead, and you're seeing the bottom of the lava tube, and that's about a 100-meter drop. And so you can imagine future lunar bases are going to be inside lava tubes where the temperature is comfortable, where there's no radiation to harm the astronauts. You just have to figure out a way to get in and out of the lava tube if you want to explore beyond that. If you want more information on any of the stories I talked about today, we've put links into the show notes down below. This is a short video version of my much longer weekly email newsletter. This is a magazine-sized email that I send out every week containing dozens of stories. There's pictures, links. You can go to all kinds of additional resources, follow the rabbit holes as far as you want. I write every word. It goes out to 50,000 people. There's no ads. You should subscribe. Go to universetoday.com/newsletter. You can also get an audio edition of everything we do at Universe Today. Just go to universetoday.com/podcast, or just search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And regular fans of the show will probably notice that I'm in a bit of a new location and a bit of a different audio sound. I'm in the new studio. Now, we haven't done it. I haven't unpacked anything. I haven't set up any of my proper lighting or sound baffling or green screen or studio or any of that, but at least I'm in a room, which is pretty cool. It's progress. If you like the work that we're doing, why don't you consider joining our Patreon? This helps support our work, supports the team, and lets us stay independent. You can find out more information by going to patreon.com/universetoday. And thanks to everyone who already supports us. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Andrew M. Gross, who supports us at the Master of the Universe level. Your support means the universe to us. All right, those were all the stories this week. We'll see you next week.